Hello, everyone. As Ernesto mentioned, my name is Patrick. I'm one of the organizers of this conference, and I really want to thank you, for coming here, especially after a couple of years of pandemic. It was a big unknown for us, to organize this conference. We didn't know how many people were going to join. So today we're going to have a look at GraphQL, which is a technology for creating APIs that you can use to communicate with from clients with a backend. And I've been using GraphQL for I think 5 years now. I always love to use the latest technologies, and I really fell in love. And today we're going to see what GraphQL is, why you should use it, and how you can use it with Python. So hopefully we're going to make all of this in time. But yeah, let's start with what GraphQL is. So GraphQL is mainly two things: is a query language and a specification. So a query language basically is what allows you to doing queries to your backend, so it allows you to get data. And the specification is something I'm gonna, explain a bit more in details later. The query language is basically something that allows you to do something like this. So you have a query here, and you wanna fetch a list of users, and then for the user, you wanna fetch the age and the name. And that means that basically GraphQL server reads the query and fetches data for you. And so when you run that query with a server, you're going to get something like this. So you can see that this matches what you were requesting. So there is a list of users, and then for every user, there is the name and the age. And this is one of the things of GraphQL, which is declarative. So you send a document, and you only get the data that you ask for. Okay, that might make sense. But what kind of problem does it solve? And to understand what problem does it solve, let's say why it was created. So GraphQL was created by Facebook in 2015, or at least open sourced at that time, to solve some of the pain points of REST. So Facebook was doing a big transition into mobile, and they were having some issues with REST, especially with low-end phones or devices in countries that didn't have a good connection. And these two problems that they were encountering were overfetching and underfetching. Underfetching is a problem where you basically don't get enough data from an API. So let's say that we're building this API here, this application here that has a page which shows the username, the age, and then the list of the top 3 friends. So we might have a REST API that looks something like this. So /API/user/IBC, which could be the user ID, and then you get the user, the name, the age, and link to the friends resource. So this is, I guess, the standard practice in REST to use links to point to other resources. But it poses a problem, because now we are able to fetch the information about the user and the age, the name and the age. But we need to do another HTTP call to fetch the list of friends. And this is a bit of a waste, because firstly, you're adding latency to everything you're doing. So every time you need to open that page, there's going to be 2 requests going at the same time, which, especially maybe at a conference, the connection is not going to be great. So you're going to get, issues with that. Or even, this happens more often than you think. You go to another country, you're in roaming, and the connection is not great. So this is a problem. I think it's still important, even if the connections are getting better. But the other thing is also requires more compute power on user devices. So there's more requests being done, more work being done by the CPU. And then the last thing, which I think it's also important for us developers, is that requires quite a bit of orchestration on our side. So we have 2 requests in the screen. We might have a lot more, but that means that we need to make some decision on what happens, when one of them fails, or if you want to wait for all of them to be done, or you want to show like partial data while the other ones are loading. And we could solve this by updating the endpoint to return more data. So we can change the endpoint to look something like this. Same data as before, but also the list of friends now is embedded into this response. This works, but it doesn't really scale well. And this is basically the other problem, which is the overfetching. So different views and clients will use different your API in different ways. So you might have some clients that will just fetch a couple of fields from that API, and other ones that are gonna, basically you're gonna have different sets of, I guess, permutation of what kind of data your clients are gonna use. And that means that, for some clients, you're gonna have bigger download times because you're fetching a massive JSON, which it's a waste. And again, you have more compute power. So how does GraphQL solve this problem? As I mentioned before, GraphQL allows to specify exactly the data that you need. So you are able to craft a query that is exactly what you want to fetch. So in this case, we are trying to fetch a user with ID 1, and then for this user, we want to fetch the age and the name. If I want to fetch the also the list of friends, I can do that by changing this query to add the friend. And you can see in GraphQL, you can also have parameters for every field, which I think is really neat. For example, here, I only care about the top 3 friends, so I can pass this parameter and only get that back. And also, I'm not fetching the age of this list of friends because I don't need that. So as I mentioned, you don't need to worry about where the data is coming from anymore, because everything is handled by a server that knows where to get all the information. And this usually works with a /GraphQL endpoint where you send this document, and then the server is going to do basically the magic to fetch all the data. So let's actually see how this works in more detail. So as I mentioned, GraphQL has a specification, and that specification says that every GraphQL server needs a schema, which is also typed. And this schema basically defines all the data you can fetch from the server. So let's see the most basic GraphQL schema. So here we have a basic type called query, which has one field called hello, which is of type string. So this is where the type thing comes into play. So every field that you're defining, you basically need to tell what kind of type it is. And this exclamation mark means that this field is always going to return something. So it's never going to be none. And one other important thing to note here is that this type query is a special type. There's 3 special types in GraphQL that they're special based on the name, and I'll show you that in a second. So every schema has to have at least one type called query, and this query, as I mentioned, is special because it's the entry point for all our data. So all the data we're trying to fetch comes from the query. So if we want to fetch the hello field, we do a query operation and say, I want to fetch the hello field. Then you can also have multiple entry points for mutating data and subscribing to events. So mentioning there is 3 special types: query, mutation, and subscription. Query is for fetching data, so it would be similar to a GET request in REST. Mutations for doing anything that can change, anything that has side effects, basically. So deleting a user, sending an email, and so on. And then subscription, I think they're really cool. They're a bit underused, I think, at the moment. They basically allow you to subscribe to events, and they work similar to query. So you can say all the data you want to fetch, and then every time the event happens, you're going to receive that data. And usually works with WebSockets. But let's get back to our user example. So we had this query, and the schema that could back this query could look something like this. So we have the type query, which is where everything comes from. So it has a field called user, which accepts an ID, a required ID, and then returns an optional person. And then the type person has the 3 fields, name, age, and friends. So I think we hopefully can understand what GraphQL is and how it works. But what's so special? So as I mentioned, it does solve some of the issues of REST. But I think we are a bit past that point now, because GraphQL does do many other things now. One thing that it does, I think it's really important, is that it makes your API type safe by default. And I think this by default is a keyword here. Because we can do something like some of these features, you can, like the tab safety, you can get it with REST using Open API. But the fact that it's by default, it's really good because you basically don't have to think about this anymore. It's backed into the API all the time. And that enables a great developer experience thanks to the great tooling ecosystem. So there is a lot of tools for GraphQL that make it easier to work with, with an API, or even easier to write an API, as we're going to see. So one of the tools that I think is really cool is called GraphQL, which we're going to see a demo of this in a moment. But basically, it's an IDE that allows you to test GraphQL APIs and to explore the schema. Then there is another one, which is called GraphQL Inspector, which basically it's almost like a linter for GraphQL, but it also does things like getting a changelog. So for example, every time you make a pull request and there's changes in your GraphQL schema, you're going to get a nice changelog. And that changelog is quite important because it also tells you if there is any field that could be breaking. So for example, if you remove a field or you change the type of a field, this tool is going to tell you, look, this change is going to break your client. And many more. I would love to do a talk on all the tools that are there, but there's too many. And there's a lot of tooling for clients. So for example, if you use React, Vue.js, Svelte, these tools make it really easy to work with GraphQL APIs. You can basically do a query in one line. It's really neat. Yeah, let me show you the demo for GraphQL, which I think, it's cool. So this is an API that I built just for this example, so it's not going to have a lot of fields, but I think it's going to explain a bit of what GraphQL is. So, as I mentioned, GraphQL allows you to test the query. So, for example, here I can try to do queries, and as I mentioned, GraphQL is typed and has a schema. So this tool knows the schema and knows how all the fields they can fetch. So, for example, here we can get all the users and their name, and then this is what you get back. Then you can do the same thing for the friends. Let's do top one, and then you can get the name for that. And the other cool thing is that you get the docs as well, and it has this neat feature which is called the Explorer, which allows you to quickly create a GraphQL API by just clicking a couple of checkboxes, which is nice. And the other thing which is important of GraphQL is the nature that it is typed. So if I'm trying to do a query that's invalid, like this one, this is an invalid query entirely, but it's basically it's not gonna try to run a query that is never gonna work. So for example, if I wanna fetch the user with an ID, maybe with a float, this is gonna complain. Oh no, actually this works. There's oh no, actually, there we go. So yeah, every time you try to do something that's wrong, you're gonna get an error. This error is on the client, but even if you try to run this, the server is gonna fail, so it's not gonna try to run this query. And this is important because you can have a lot of fields, and you don't wanna do any execution of those fields if the query is invalid. So we do have some ideas of how we can use GraphQL API, especially that all the work that we've done is basically kind of front end. So let's see how we can implement them using Python. And I'm going to use Strawberry, which is a library that I created, I think 3 years ago or something like that, with the goal of creating a library that's really easy to use, which has a nice API and also has a nice community. And I can see some people from the community here, which is really nice. So Strawberry basically allows you to create GraphQL APIs using Python type-ins, which I think they're a really good fit for GraphQL. And I'm going to do like a quick deep dive on type-ins and what they are, because they are still quite new in Python. So they're a newish feature of Python that allow you to annotate the code with types. So for example, here we can have a function called getUserNames, which accept two parameters, ID and first. And ID should be a list of integers, and first should be an integer with 10 as default. And then the return type is a list of strings. When I try to run this code, Python doesn't really care about the type-ins. It's almost like they don't exist. So it's not like Python is now a type language. They are basically annotations that can be used by tools like, for example, MyPy and Parite, which are type checkers. So you can run type checking in runtime. So for example, if you run this function passing the wrong types in one of the list items, you're going to get an error from the type checker. There's a bit of controversy on the fact that Python is adopting types, but there is a lot of companies, especially large scale, that are using them, and it does save a lot of time. It does save a lot of time when you're working, especially with a big code base. But the other cool thing is that I think Python is probably one of the few languages that can do this. Type-ins can be used at runtime. So that means that you can basically introspect your code and do interesting things with the types. So you have an example function that accepts one parameter called int and returns a string. Then when I use the dunder annotations property, I can see the return types and the parameter types. And this is basically what makes Strawberry possible. So we are going to see this in a second. We introspect your code, and we basically generate GraphQL types from your Python code. And there's many other libraries like actors, data classes, and so on that do similar thing. So let's see how we can make Hello World with Strawberry. So this is the schema that we had a look before. So this maps quite neatly to Python. So you can create a class called query, and you can add a field called hello, type string. And this is how you can, basically annotate your Python code using annotations for a class. And then all the magic is done by this strawberry.type decorator, which is basically what I said is gonna, introspect your query, get all the fields and create a GraphQL type for you. So yeah, it reads all the type ints and generates a GraphQL type for your class. And then the last thing we need to do is to basically tell Strawberry that we want to create a schema based on this query. And that's basically it. So just a couple lines of code, and I think it's a really nice syntax. You can create a GraphQL API just like this. So that's cool. We had defined a schema, but what about the data? So this it's a schema, but it doesn't really do anything. So we want to fetch data, and in the way you do this in Strawberry and probably in other GraphQL implementation is by creating functions. And here we're saying I'm creating a hello world function that returns just a string, and then we can use the strawberry.field function to pass this function to the field, right? And this resolver keyword here is basically what maps this field to this function. So resolver are concept in GraphQL, and they are basically functions that are called when a field is requested. So every time you try to fetch a field, there's going to be a Python function that's going to be called. So, we can also use resolvers to attach parameters to your field. So let's say that we want to fetch a user which returns an optional person, you want to fetch it by ID. So in Strawberry, there's not really a way to define the parameters on the fields directly. You need to go through the resolver. So here, we define a function called getUserById. We're saying that we want to receive an argument called ID, of type ID, and then we're doing some code to fetch that ID. Then we do the same thing as we've done before, so passing the resolver to the field, and then that's basically it. So this is combining the field and resolver to create a field with arguments. Hopefully that's clear, but I'm going to show you the code now because I think it's easier to understand with the code. So this is a code that wrote for this code, and this is using Django, but it's not really that important because Strawberry works with many frameworks, works with FastAPI, Starlet, and so on. And all the code that we're going to see, most of the code that we're going to see is Strawberry specific. So as I mentioned, you can use strawberry.schema to create a schema based on a type. And this query type here has two fields, user and users. And as I mentioned, they both get resolvers. So let's see the resolver for getting the users by ID. So this one, as I mentioned, is specifying the ID parameter, and this is what you see here. So that Python code maps to this field here. So there is a user that returns an optional person and accepting one ID, which is here. And then all this code here is basically doing database operations using Django. And I was trying Django, the latest Django alpha, just to see if everything worked with async stuff. But that's not too important for this talk. Let me see if there's anything interesting from that. For the same thing we do for getting the users. So we have a getUsers resolver, and it basically does the same thing. It just runs some database call using Django. This sync to async is something, just if you're curious, it's not important for the talk, but it's something that's built into AsGraph, which allows you to run synchronous code as async, because at the moment Django has some issues with running database queries into async code. And maybe it's also important to mention that Strawberry works with both async and non-async code. So this could become something like this, and it will still work. Because we don't really care what kind of code you want to write. We want to support both async and non-async code. I think that should be it for the code. So let's do a quick recap for what we've seen. So we see now Strawberry uses type-ins for creating GraphQL schemas, and we've seen how we can use Python functions as resolvers. So we've seen how we can basically tell our GraphQL server to fetch the data from our database, or it could be anything else, really. And we see now we can use parameters on the resolver to add parameters on the GraphQL fields. I'm going to just do a quick plug. I'm basically done. I'm going to do a tutorial on this. There is a lot of things related to GraphQL. I wanted to put more, but yeah. This tutorial is going to take 4 hours, so I didn't want to bore you. But yeah, basically I'm going to do this tutorial next month at EuroPython, which is basically going to teach you how to use Strawberry. So we're going to see some of this, but we're also going to see what makes GraphQL production ready, basically. So you're going to see things like making sure that the performance are fine, authentication maybe, and just best practice for writing queries. Because it's a new technology, it's a bit different from other things. And this is the website for Strawberry, so you're going to see the docs, you're going to see links to GitHub and our Discord server. And yeah, thank you, everyone. Yep.
Okay. Thanks, Pat. We do have a few questions, so I'm going to start reading the first one. If Slido, I can rely on Slido, I don't know. Okay, so the first one is, Strawberry is interesting. Does it provide a way or any plans to auto-generate the Python code from the schema? It's useful to start from the schema, so that is shared between front-end and back-end.
Good question. Maybe. I mean, so this is a bit nuanced, but you can, so in GraphQL you have code first and schema first. So schema first, you basically write the schema that we've seen here, something like, like this. And then you maybe attach Python functions from the schema with a different API. Or you can write Python code to basically generate that. I guess I'm biased because I really love using code and using the types in Python. I don't know if we're going to have native support for this. It would definitely be interesting to chat about this. We do have some CodeGen thing working. We wanted to implement generating Python code from a schema, GraphQL schema, but it wouldn't be like real time. You will always need to generate it at some point. Yeah, hopefully that answered the question. So I'm happy to take any explain things a bit more later as well. I'm going to be around the conference.
Okay, thank you. Next one is some cons on using GraphQL. Why isn't everyone using GraphQL over REST APIs?
Yeah, I mean, why everyone isn't using it? I think it's because it's quite new, and there's a bit of, it's always hard to introduce a new tool in your code base. So I guess you need to study a bit how it works. I think some of the cons might be, it's a new thing, so it's hard to sometimes to follow the best practice, because especially at the beginning there were not many best practices. So you can make queries that couldn't be that performant. So you're trying to solve a performance issue with GraphQL, and then you get a query that's actually not performant. So that's something that is still, I would say, is still not easy with GraphQL at the moment if you're trying to do something that's quite complex. There is a lot of work being done in monitoring toolings, so you can see what is actually taking a lot of time in a GraphQL request. The other thing is GraphQL is also a different approach. Like with REST APIs, you expose resources, which usually is easy to be defined in your code base. With GraphQL, the idea is that you actually work for the front end. So you're trying to make types and APIs that actually match some use cases. And I've seen a lot of people that have this backend mindset that it's basically going to expose your database, and you should not do that. Yeah.
Thank you. Next one is, in your opinion, what is the best DBMS to use with GraphQL? I mean, what are the options that you can use as DBMS?
Good question. I mean, I don't want to say this, but it depends. It depends on what you're building. So GraphQL is quite agnostic on what you use. Like I've done APIs that GraphQL APIs actually talk to other services. So GraphQL is doing the REST API calls to that, and it made sense there because the database wasn't directly exposed to me. So yeah, there's not really a answer for this. I mean, I really like using Django because I know it a lot. And I use Postgres with that. But you can use anything basically.
Good. So you mentioned that subscriptions are still underused.
Yeah.
Why?
Question. I think the main issue of subscription is that it's hard to scale them. So to have a subscription working, you need to have a server that's running all the time. In a period of we have a lot of things running on serverless, and I don't think subscription works on serverless. So you basically need to have a server running all the time, and then you need to make sure that it also scales well, which is still a bit hard. Yeah.
Great. What is relay endpoint if it?
Relay?
I don't know. I mean,
what is relay endpoint of it? Oh, okay. Relay is also a thing, or I guess a technology from Facebook, which is almost like an extension of GraphQL, and it provides some best practices for, I think mostly for pagination. I don't use Relay, so I'm not really familiar with it. All the reason why you would use it. If you see in GraphQL, if you see an API that's pagination, it has edges and nodes, that's usually coming from Relay, which is basically, GraphQL doesn't really have a lot of best practices, as I mentioned. So doing pagination is something that is usually always, it's always different in different APIs, and Relay kind of solves that because there is a standard way of doing it.
Okay.
But you don't have to know it.
Yeah. There is an interesting one, I believe. I mean, people like your T-shirt. They want to know where to buy it.
Where to buy it? This is a limited. I did this on my own for Marco. She's a friend of mine. Yeah. Maybe we'll sell them, but they're going to be expensive.
Yeah, but then we have to pay the fee.
No.
Yeah. I know him. Yeah, getting serious. An insight for implementing authorization. For example, a requesting client does not have access to certain points of the schema.
Yeah, that is a good question. So we do. So usually in the APIs I build, I tend to really to leave the authentication part to my framework of choice, like Django. So handling sessions or using things like Django JWT to use tokens. We do have some support for permissions. So this is something that was inspired by Django REST framework, which basically you can add a. So in addition to adding a resolver to a field, we can also add a list of permission classes, and every time that field is requested, we check the permissions first. There were some, bit of discussion on that. Does it make sense to have authentication on GraphQL or not? Like permissions on GraphQL. So we still, trying to figure out the best practice for this in Strawberry list. So there is, there's different opinions between different people. So, do you want to leave the permission stuff inside your, API, or do you want to put it near your business logic? I think it makes sense to have it on the business logic, but, I think it's also useful to have it on GraphQL as well for, quick things, making sure that, this field is only for authenticated users, and then you do the other checks inside your business logic.
Okay, thank you. I think we have time only for one question more. Okay. So for the other one, maybe you can reach out, Patrick, in person.
Yeah, definitely.
So the last one is, does GraphQL limit the possible of server-side cache, isn't it? Yeah,
that is a good question. So I haven't shown you this, but every time you run a GraphQL query, like by default, the query is doing it's not showing it, but it's doing a post request. So, and post requests are harder to cache. So there are ways of, changing this to be GET requests. I think we have support for some of the frameworks for that. So if you change it to be a GET, then it's easier to cache. I don't remember why it was done post by default, I think it might be to have some limits. So, if you have big queries that don't fit the URL parameters. But yeah, caching is definitely harder for sure. So again, there's different ways of doing that. So you can use GET requests. So you can use tools like GraphQL CDN, which basically does the cache for you. Oh, and not connected to the internet.
You can rely on the internet connection.
Yeah. Yeah, but you can also do. We do have some caching built in, I think. We are working on doing something that's called persistent queries, which are basically a way to convert a query to an ID, and then instead of sending in the query to the server, you send that ID, and then that makes it much easier to cache because you have an ID that's stable. But yeah, I should probably write something about this. It's hard to explain.
All right. So we run out of time. Thank you, Patrick.
Thank you.